What is up, YouTube? It's Trent here with Visual Torch, where cybersecurity meets clarity. In today's video, we'll be going over days 13 through 15 of TryHackMe's Advent of Cyber. If you are new here, we have been going over each day of TryHackMe's Advent of Cyber. So we've done 1 through 12, and TryHackMe's Advent of Cyber is a 24-day challenge where each day a new room gets unlocked. And these rooms cover topics from basic cybersecurity things like cloud security, digital forensics, phishing scams, and more. So if you're new to cyber and want to learn how to level up your skills, this is a great place to start. And every day that you complete a challenge, each room completed will give you a ticket that will enter you into drawing for all different type of prizes, and the total amount of the prize pool is going to be over $150,000. So I best suggest that you go ahead and enter, and we'll go ahead and get started. Okay, and we left off on Yara rules. Yara mean one. So go ahead and click on this and get started. So if you are joining in, you have any questions as we go along, want to talk anything about cyber, just drop it down in the chat and I'll be more than happy to answer any of your questions. Let's just refresh this page. It looks like it logged me out. Give me one moment. Okay, we are back. Let's go ahead and join the room. Okay, so here's the story for day 13. When McSkitty went missing, there was chaos and uncertainty at the Best Festival Company. However, even in her disappearance, McSkitty was trying to help the TBFC Blue Team. Taking a page out of the crisis communication process, McSkitty sent what looks like a bunch of images to the Blue Team from an anonymous location. These images looked like they were related to Easter preparations, but they contained a message sent by McSkitty. The crisis communication process outlines that a message might be sent through a folder of images containing hidden messages that can be decoded if you want to know the keyword. The Blue Team has created a Yara rule that runs on the directory containing the images. The Yara rule must trigger on a keyword followed by a code word. After extracting all the code words in ascending order, the Blue Team will be able to decode the message. So this will give us a basic understanding of the concept of Yara. We'll learn when and why to use them. We'll explore different types of Yara rules and learn how to write them. And then we'll practically detect malicious indicators using Yara. Let me go ahead and spin up this machine. And we'll be working inside the Easter folder in Ubuntu downloads. So I'll wait for our VM to pull up. We will go over the Yara rule overview. So at this stage, McSkitty, the lead defender, has entrusted you with a mission involving the use of Yara rules. But before we can jump into this action, we need to take a closer look at what it is, how it works, and why it's such a valuable tool to fight to protect SOCMAS. So Yara is a tool built to identify and classify malware by searching for unique patterns, the digital fingerprints left behind by attackers. Imagine it as a detective notebook for cyber defenders. Instead of dusting for fingerprints, Yara scans code, files, and memory for subtle traces that reveal a threat's identity. So, why it matters and when to use it. You're wondering why Mosquito would choose this tool for the mission? In the world of cyber attacks, defenders face an endless stream of alerts, suspicious files, and anonymous network fragments. Not every threat stands out. Some hide in plain sight, disguised as harmless documents, and that's where Yara shines. So it's going to be able to give us insight into actually what is going on with these seemingly harmless files. So we can utilize it in post-incident analysis. It can be used in threat hunting, where we can search systems and endpoints for signs of known or related malware families. We can use it in intelligence-based scanning and memory analysis, where we can examine active processes in a memory dump for malicious code fragments. So in a constant battle to protect SOCMS, time and precision matter. That's where Yara shows its true value. It gives defenders clarity in chaos. With Yara, you're not waiting for an antivirus update or third-party alert. You have the power to create your own rules, detect variants, and act before the threat spreads. So we'll be able to use its speed, flexibility, control, shareability, and visibility to give us an understanding of what's going on. And as we go through this, we'll see just how powerful Yara rules will be. So a Yara rule is built from several key elements. Will be metadata, which will be information about the rule itself, who created it, when, or for what purpose. So every time you create a file, there is metadata that is left behind from pictures, anything. Then you have strings, which are the clues Yara searches for. They can be text, byte sequences, or any other regular expression that marks suspicious content. And then conditions. This is the logic that decides when the rule triggers, combining multiple strings or parameters into a single decision. So this is how it would look. So this is the actual rule that it created. And in there, they're saying, hey, let's search the metadata for an author by the name of Defender of SOCMS. This is the description we want, and this is the date. And in the string, which is any text that could be found, they want to look for this run_dll32.exe, and we'll learn more about what the full word and this means. But then we also have the msvc rt.dll, and if it's pointing to a specific URL, and it says if any of these conditions are met. So if it hits on just one of these, then we'll be able to take a look and see what it pulls out of there. So we can go down here because it's basically explaining the same thing. So strings, as mentioned earlier, strings are the clues that Yara searches for when scanning files, memory, or other data sources. They represent a signature of malicious activity and fragments of text. Bytes are patterns that can reveal the presence of key malware's code. In Yara, there are three main types of strings, each with its own purpose. So they'll be talking about each one. So we have text strings, which are the simplest and most common type of Yara rules. They're just short fragments that may appear in a file, script, or memory. So you can see in here, they called the valuable for the string, and they're looking for anything named Christmas in the string. And it says sometimes they try to hide their code by changing how the text looks inside a file. They may try to encode it, they may use different cases, or they may even try to encrypt it. So by default, Yara will look for the text exactly as it's written, but if you don't care the case sensitivity, you can add the no case modifier. So look for all verification. And then we have the wide string characters, in this case, wide ASCII. So by adding wide, it tells us to also look for this format, while ASCII enforces a single byte character. So it's looking for, so here you can see in Christmas, it says look for wide or and ASCII. And then we have XOR strings. Malware's agents often XOR encode text to hide it from scanners. Using the XOR modifier, it will automatically check all possible single byte XOR verifications to try and figure out, try and reveal what they're trying to conceal. And then if something is base64 encoded, it will go ahead and we can actually scan by using the base64 code word there. And then actually we can also look for hexadecimals, strings. So sometimes King malware code doesn't leave readable words behind. Instead, it hides in raw bytes deep down inside executable or memory. That's when hexadecimal strings come to the rescue. Hex strings allow Yara to search for specific byte patterns written in hexadecimal notations. So they'll be able to detect them in fragments like file headers, shell codes, or any binary signatures. And then here is regular expressions. So it's saying that sometimes his code mutates, so there may be small changes to file names, URLs, and commands, making it harder to detect. So that's where regular expressions, which is regex, and that allows defenders to write flexible search patterns that can match multiple variations of code. And you can see it right in here. And then we have the conditions. And then this is just what to look for when using strings. And if one of these conditions should trigger, the YAR rule will tell you when it triggered and tell you what the code looks like. So the simplest condition, the rule triggers on a specific string. So we can search for any one of these strings, or we can search for a specific one, or we can say if any of the strings matches, then we have a hit, or we can say if all of the strings required together, then we'll be able to get our positive. And then also you can use logic to combine the conditions using and, or not. So in this case, they said, hey, if string 1 or string 2 hits and it's not string benign, then it's good. Then it is detect that it's suspicious code. And then we can use comparisons like file size, entry points, or hashes. So they said if it hits on any of them and the file size is less than 700 kilobytes, that the YAR conditions will hit. So the evil kingdom of malware used a Trojan known as ICE ID to steal credentials from systems. McSkitty's analysts discovered that the malicious files spread across Wareville shared a common signature, the same MZ header found in executable malware used by the Dark Kingdom. These samples are small, lightweight loaders designed to infiltrate systems and later summon more dangerous payloads. So this is a sample of what the whole YAR rule would look like, where they were looking at the author, the description, the date, and the confidence inside the metadata with these hexadecimal strings. And this is where we see it wanted all of these to hit with the file size. And this is the actual command they use to run YAR with inside the terminal. So we can use man YAR, which is the man pages or the manual, to find different type of strings. So in our actual assignment, we're going to be taking a look and creating our own YAR rule. So they will say the blue team has a search for the keyword TBFC : followed by the ASCII numeric keywords across, and this is Easter directory. So it wants to know how many images contain the string of TBFC. So we'll open up our terminal. Let's just create a file. We'll call it nano Easter.yara. And then I will say, let's go up here so we can get his rule. Curly brackets, and we're looking for a string. So we'll start with strings. We'll say S1. S1. We'll say equals TBFC. Was condition That's one. Let's make sure I'm not missing any others. So yes. Actually, I want to copy. Actually, I want to move this to the downloads folder. Easter. Oh, doggone it. Oh, sorry. Easter. I put Easter. Oh, I did put Easter in here. Doggone it. Hold on. Really? Okay. So this is all the list of files here. And then what I'm going to do is we are going to Easter. All right. Actually, let me go back and mod that. X. Okay, whatever. All right. Easter. I'm going to do Easter.yara. And we are going to tag R. Actually, let me see. It is in this directory. Strings command not file. Strings command not file. All right, go back and edit this. Strings, $sign. Oh, that's what I forgot to call Yara. Yara first. Yara. So we got Yara. And let me put a tag R. If I can type, this would be fine. All right. Period. There we go. So we have 1, 2, 3, 4, 5 files. So how many images contain the string TBFC, which will be 5. We'll check that. It says, what regex would you use to match the string that begins with TBFC? It says, followed by one or more numeric ASCII. So that would actually be went back up here, we talked about regex. So we will actually use this right here. Put that there. Plus undo? No. All right. That. I have to do plus. There we go. Oh, there's a slash actually. There's a slash this way. And there's another slash. There we go. And then there should be a slash at the end. Missing. We're missing a bracket. TBFC. Do I need to plus sign or not? Right. Ah, don't need the plus sign, that's why. I think it's this one. All right, that's what it is. Save this. Okay. And now we have to find the message that is left behind. So now if we run this and we do attack S, we will get hopsec find me island in. So we can see that this should probably be find me in hopsec island. Check that. See if it's gonna go. Yep, so we did finish this day and we're done with day 13. We have tickets. Now we can move on to the actual next day. Go back to Wareville. And now we have containers. And okay, so with this, seems like as the sun rose this morning, it was already decided that today would be another day of chaos. At least that was the feeling for the folks that DoorDasher got. DoorDash is Wellville's local food service delivery site, a favorite with the workers in the TBFC, especially on long days when they get home from work and just can't bring themselves to make dinner. We've all been there, I'm sure. Well, one Wellville resident was feeling particularly tired this morning and decided to order breakfast, only to find that King Milehair and his Bandit Bunny battalion had seized control of yet another festive favorite. DoorDasher had been completely rebranded as Hopperoo, and all of the Ware's favorite dishes had been changed as well. Reports started flooding in to DoorDasher call center, and not just from customers. A health and safety food org was on the line too, utterly panicked. Apparently, multiple Wareville residents were choking on what turned out to be fragments of Santa's beard. Wareville authorities were left tangled in confusion today as Hopperoo faced mounting backlash over reports of culinary impersonation. So we will be tasked with learning how containers are working and including images, layers, and container images. We will explore the Docker runtime concepts and the common container escape privileges escalations. Apply these skills to investigate the layers and escape the container, escalate privileges, and restore DoorDash's service. So we need to make sure that we get everything back to order. And do not order Santa's beard pasta, as you can see from up here. He said it called it an assault on Italian cuisine and my immune system. That would be utterly disgusting if I ran into that. So I'll go ahead and start up the machines. So if you're just now tuning in, we did finish up day 13 of TryHackMe. We're on day 14. If you have any questions, what we're doing along the way, feel free to drop them down in the chat. If you just want to chat about your cybersecurity journey, let me know. I'll be happy to answer any questions you have. So I think okay, so they recommended that we switch to full screen mode for these. So let me open up 2 more tabs. That one's up. I think I have to. This one's still loading. All right. I'll just exit full screen over here. Okay, so what are containers? So containers are modern application. They're modern applications, but they can be a bit more complex. They fix a more complex problem. So they fix installation. So depending on the environment the application is being installed on, it is not uncommon to run into configuration quirks, which make the process time-consuming and frustrating. And then we have issues with troubleshooting, or when an application stops working, a lot of time we have to waste on trying to figure out what is the problem on the application itself or the environment. And then we run into conflict issues when it comes to modern applications. Sometimes multiple versions of an application need to run, or perhaps multiple applications which need different versions of Python to be installed, and that can come into different conflicts with dependencies. So if you're reading these problems, your brain conjured up the word isolation as a solution. Well, if your brain did, you are on the right track. Containerization solves these problems by packing applications along with their dependencies into one isolated environment, and that package is known as a container. In addition to solving all of the problems above, containerization offers further benefits. So one of the benefits is how lightweight it is. So this below is an example of the container architecture. So here is your modern machine virtualization, where you'll have a VM running on a hypervisor, and then all of these different apps, bins, and libraries in there. And then when it comes to your actual containers, they will share the host OS kernel, isolating only applications and their dependencies, which makes them more lightweight and faster to start. Virtual machines are ideal for running multiple different environments or legacy applications, while containers excel in deploying scalable, portable microservices. So if you are getting into cyber, this is one of the things that people started talking about. You probably heard of Docker containers, and they found ways that they can spin up images of things super, super fast with these containers instead of doing machine virtualization. So it talks about application at scales. So microservices are a switch in the style of application architecture, where before it was a lot more common to deploy apps in a monolithic fashion, built as a single unit, a single code base, and a single executable. More and more companies are choosing to break down their applications into parts based on the business function. This way, if a specific part of the application receives high traffic, they can scale that part without having to scale the entire application, which helps with the lightweight part of it. And they make it easy to scale, to meet increasing demand, so they can scale them up and scale them down as need be. You may have noticed a layer labeled container engine in the diagram. A container engine is a software that builds, runs, and manages containers by leveraging the host OS kernel features like namespaces and C groups. One example of a container image is Docker, which we will examine more in detail. It is one of the more popular container images, and it uses Docker files, which are simple text scripts defining app environments and dependencies to build, package, run, and manage the applications consistently across the systems. So this is the actual engine of choice for DoorDasher. So Docker is an open source platform for developers to use, manage, and deploy containers. So we'll be talking about the escape, attacks, and socket. So a container escape is a technique that enables code to run inside a container to obtain writes or execute on the host kernel or other containers beyond the isolated environment. So what they're trying to do is actually get out of that isolation and be able to run stuff on maybe a host OS or more infrastructure. And that is a form of like privilege escalation. So containers use a client server set up to host. The CLI tools act as the client, sending requests to the container daemon, which handles the actual container management execution. You have runtime. The runtime exposes an API server via Unix sockets to handle the CLI and daemon traffic. if the attacker can communicate with that socket from inside the container, they can exploit the runtime. And this is how we create the privileged container with internet access, as mentioned in the previous example. So our goal is to investigate the the Docker layers and restore the defaced Hopperoo website to its original service, which is DoorDasher. And we're going to walk through these steps in this challenge together. So what we'll do is we'll go over to the actual machine that is running the Docker, and we're going to run Docker PS. So here, it gave me the, this is, actually, before that, let's take a look at the actual site. So we can see the actual defaced website. So here we can see the Hopperoo website, and we can see, mythical soup broth, Wild West cuisine at Christmas, literally just hair, no pasta at all. So this is all the reviews that were coming in. So if we go back here to where the Docker containers are being hosted, we can run a Docker PS to see all the services. And we can see this right here, Dasher app. Is where Hopperoo is running at. So we could run the following command, which is docker exec uptime checker. To try to access the uptime container. Don't see the clipboard over here, so it was Docker exec IT checker sh. And then now we're actually in the uptime checker, and we can say probably just root, check what's in here. So we have so we're here in the root directory. And then now it says, let's check the socket by doing ls var run docker.sock. Okay. var run docker.sock. Run docker.sock. And it says the Docker documentation mentions that by default, there's something called an enhanced container isolation, which blocks the container from mounting the Docker socket to prevent the malicious access to the Docker engine. Some cases when running test containers, they need the Docker socket access. Let's see if we can access this directly, which is got there, we LSLA'd. It says, I wonder what happens if we try to run commands within there. So if we run docker ps again, we can still see the Docker services that's running. So we can still interact with the API, so we can try to perform a Docker escape attack. So it says, let's instead try to access the deployer container, which is a privileged container, and we'll run the same Docker exec deployer.bash. Okay. Docker exec it deployer bash. Now we're on this deployer in here. So it says that we can type who am I and check and see which user we're currently at, and we can try and explore the container to find the flag. So let's run apps. So let's backtrack. Is there anything in here? We do have a flag, so let's cat that flag.txt. And now we have the THM Docker escape success flag. Okay. Which should probably be a question. Okay. Docker escape success. So we got that flag, and it says to run the recovery script. Okay. So there is a recovery script here. So we're going to sudo it is running. So it says the hackers have been defeated. So now if I go and refresh this page, we are back to DoorDasher. So it says what exact command lists the running Docker containers. So that was Docker PS. And then what file was used for the instructions. So if we remember in the beginning, that was a Docker file. We should be good to go. It says the bonus questions, there's a secret code contained within the site on port 5002. And it says it is the password. We need to find it. So if we go here and change this port, looks like, yeah, in red letters they outline deploy master 2025 exclamation point. Let's see if that runs. Okay, we're done with that. Should be it for this room. And now we can move on to day 15. All right. If you're tuning in and you want to stay up to date to everything we are doing, follow along for more of our Advent of Cyber, do us a favor, like, subscribe, and hit that notification bell so you can follow along. So we'll be moving into day 15. And this one is Web Attack Forensics, Drone Alone. So actually, all right, let me terminate these other machines. Okay, we're back on the attack box. Okay, so the TBFC's drone schedule web UI is getting strange. Long HTTP requests containing base64 chunks. So Splunk alerts that Apache spawned an unusual process. So on some endpoints, these requests cause the web server to execute shellcode, which is obfuscated and hidden within base64 payloads. For this room, our job as a blue teamer is to triage the incident and identify compromised hosts, extract and decode payloads to determine the scope. And then we will use Splunk to pivot between the web of Apache logs and the host level sysmon telemetry. And we will follow the investigation steps below, and each corresponds to a Splunk query and investigation goal. So we'll learn how to detect and analyze malicious web activity through Apache access and error logs. We'll investigate OS level attacker actions using sysmon data. We'll identify and decode suspicious or obfuscated attacker payloads. And we will reconstruct the full attack chain using Splunk for blue team investigation. So if you do remember, you went through the Advent of Cyber so far. We've already used Splunk. So this is kind of like a refresher a little bit with a little bit more things involved, seems like. So we will, once this machine pops up, we will be able to log in with this username and password. Give it a moment. So yeah, if you drop down in the chat just how you guys are enjoying the Advent of Cyber so far. Anything that you've learned new, anything you're hoping to see during this time. Just want to hear from you all. Right, it is almost up. So let's go ahead and navigate to this site. Let's see what's going on with you. Nope, that is fine. There we go. So now it was blue, it was pass 1, 2, 3, 4. And now we should be here for the actual logs. Once that logs us in. Yep. Well, still sign us in. Let's see what we have to do. So we just want to make sure that we change our time of events from last 7 days to all time. So that way we have, well, we can change it to last 7 days or all time. Just make sure we cover everything. So our first step is let's search for HTTP requests that may show the malicious activity. And there's a query below here that we're going to run that will check the logs for any HTTP requests that will try to show execution of the command.exe, PowerShell, or invoke expression. So this helps us identify any possible command injection. So let's go ahead and copy this. And let's change this from last 24 hours to all time. So it looks like we do have running execution. So it looks like command shell with PowerShell.exe. Sorry, command with PowerShell.exe, and it looks like this is some type of base64 encoded. So it says yes. So once we spot the encoded PowerShell commands, we can try and decode them using base64 decode.org. You could do that, or what you could actually do is you can debug it. You can decode it straight from the terminal. So if we go here, ready. So if we go here and we just echo this, and then we pipe base64 tech-d, and that's what it was saying. This is now mine, and moo ha ha ha. So we went ahead and we decoded it. So, or you could use something like base64 decode.org, and you can do the same. And it says now we're going to look for server-side errors or command execution in the Apache error logs. In this stage, we'll focus on inspecting the web server logs, as this will help us uncover any more malicious activity. So we're going to run this other command here, where we're looking for internal server error, looking for PowerShell. It's not letting me track this. Come on. There we go. And it will inspect the Apache logs for any signs of execution attempts or internal failures caused by malicious requests. And we will be, it tells us to make sure we select raw as our view. Okay. Here, search for this. And then our view was supposed to be raw. Now we can see that when it tried to run it, is not recognized as internal or external command. So we do see we have logs there for that. And if we go back, it says if a request like the CGI/Bing hello.bat equals PowerShell triggers a 500 internal server error, it often means the attacker input was processed by the server but failed during execution. So it shows us that they are trying to exploit, but it was just unsuccessful. So next we're going to do is we're going to trace the suspicious process creation. So we're going to do that by exploring sysmon for other malicious executables on the web server that may have spawned. So we're going to look for this httpd.exe. I always forget about this clipboard for some reason. I normally don't use the TryHackMe attack box. I just use my own. So that's probably why I keep forgetting. Let's put this back to table view. So it can look right here that hello.bat was running. This is not exe, well, cmd.exe. See if I can expand this out. Okay. Now if we go back here, it's telling us, yeah, that it tried to, that it was trying to spawn processes like cmd.exe or PowerShell, which Apache should not. So this indicates a successful command injection where Apache executed the system command. And now we're going to look for the attacker enumeration. So in this step, we will try and see what specific programs we found from the previous queries. So we'll run this command. So we'll look for cmd.exe and see if they tried to use who am I. So what happens a lot of times is, like you saw on the last box, once you get on an actual machine, you try to figure out exactly who you are, where you are. So a lot of times attackers will do a who am I real quick just to see what user they are. But like we're going to see now, that's logged. If you're logged into a box, you should know exactly who you're logged in as. So a bunch of who am I commands would be suspicious. So you can see there is a whoami.exe that was running on Apache and about 4 times. So it's not very good OPSEC to spam who am I when you get onto a box. So there is post-exploitation reconnaissance. So they, like I said, they were able to get on the box. And then it says to identify base64 encoded PowerShell payloads. So in this final step, we will work to find all successful encoded commands, and we will search it by using this string. And let's go back here. If you're just tuning in, I am Trent with Visual Torch, where cybersecurity meets clarity. So we are going over day 15 of TryHackMe's Advent of Cyber. We just went through day 13 and 14 earlier. So we're going to run this command, but no logs have shown up. So it says, if your defenses are configured correctly, this query should return no results, meaning the encoded payload never ran. So that's what we saw. And then it says, what is the reconnaissance executable file what was the name of it? So remember, they're trying to figure out who they were. So it should be who am I, .exe. And there we go. And it says, what executable did they attempt to run through the command injection? So when they originally tried to do the command injection, they were trying to encode it by using PowerShell.exe. That's what we should see. Yeah, right here, this is where they were trying to do the command injection. So if we go back down here, we type in PowerShell.exe. We are now completed the last box, so we're all caught up. So yeah, that's it. I'm Trent with Visual Torch, where cybersecurity meets clarity. If you do like these videos and want to tune in to see us do more of TryHackMe's Advent of Cyber, do us a favor, like, subscribe, and hit that notification bell, and we'll be on tomorrow. So have a great day.